does that have to do with my inner me? True story. Hey, at least we ain't going. There was absolutely no glory in that category.
What? Mom, you can't come in and interrupt my TikTok like that. You gotta knock first, Mom. Jeez. All right, everybody, here we go. Math 7-8. Welcome to your third online lesson. We're hitting 9.4 today. But before we do that, I gotta tell you how much I miss you guys. If I ever complain about you guys talking too much, just remind me how bored I was in this room all by myself. Can't wait to have you guys back, even when you're talking. Although I'm so old I'll forget and I'll start yelling at you all over again. But I really do miss you guys. All right, here's our joke of the day, everybody. The joke is on me. Hey, there's Danny Olson back in high school. 1980s. My mom always wondered where the hairspray of hers went. But what a cool mullet, huh, you guys? Beware. This is going to happen to you someday. Especially if you don't do your homework, everybody. Okay, here we go. Let's first talk about our cube roots. We discussed some cube roots today. Let me get those answers back to you. Hit pause. Go get your homework. Are you ready? You better be. Here we go. Number 4. If the volume of a cube is 216 inches squared, then each side must be 6, because 6 cubed is 216. Number 5. Each side must be 1/3. Number 7. The cubed root of 729 is 9. Number 8. The cubed root of negative 125 is a negative 5. Because remember, cubed is 3 times. You could end up with negative numbers, unlike our square roots. Number 9. The cubed root of negative 1000 is a negative 10. Number 13. Ooh, that cube root and that cube should cancel each other out, shouldn't they? Which means 18 minus 27 is a negative 9. Number 15. The cube root of 729 times 5, then subtract 24, you should have gotten 21. Number 19. Ooh, if n is 500, plug in that number, do your division, find that cube root. The answer to number 19, everybody, was 55. Number 20, you should have an answer of negative 276. Moving right along, everybody. Number 22, x is equal to 2. Number 23, t is equal to a negative 7. Number 24, y is equal to a negative 5. Number 25, z is equal to 6. Number 26, h has to be equal to 3. And finally, everybody, we got to answer question number 33. Which side is bigger? The right side is bigger. You should have a less than symbol in there. Less than. And that takes care of last night's homework. So, everybody, here we go. We're off to... It's called 9.4. 9.4, everybody. Here we go. We got to convert between different forms of rational numbers. We got 10 problems for homework. A few of these are super easy, and the rest will be a challenge. Can you handle it? I know you can. No big deal. All right? If you get stuck, you can always look something else up on YouTube. Khan Academy. Best answer is to look back at those examples in the book. Okay, everybody? Make sure you read those few pages before. Hit me up with any questions if it's simple enough to email me. Otherwise, we'll just keep trucking along seeing what we can do. All right. Well, let me tell you about today's lesson, everybody. We're going to convert... We're going to be talking about rational and irrational numbers. I got a cool little flow chart here that I'm going to have as an attachment. So you should be able to download this, take a look at it. Help you determine whether the number is rational or irrational. Well, for now, let me just tell you the basics, everybody. A rational number has that word ratio in it. If you can write it as a ratio, it's a rational number. If you can't write it as a ratio or a fraction, it's an irrational number. And we're going to come back and talk about some of those guys later. All right. So, we're going to start talking to everybody about our rational numbers. Rational numbers can be in decimal form, they could be in fraction form, and of course, we got to be able to convert between these two different languages we need to be able to speak. First thing is they're going to give you some fractions that you have to write as a decimal. Remember, a fraction is just a Oh yeah, nobody's here. An unsolved division problem. Who goes in the house? Top dog goes in the house. Now we're off using our calculators. Feel free to practice your long division skills, but I'm totally okay with using a calculator for a couple of these problems. They give you a question like 1 and 4/25. That's one of our examples in the book. 1 and 4/25. Well, obviously it has to be a 1 point something, so all I gotta do is say what's 4 divided by 25, and I get 1, 6, 6, 6, 6, 6, 6, repeating. So that's my answer. 1.16 with the 6 repeating. So when they ask you to convert any fractions to decimals, simply do the division. Shouldn't be too bad. It's the next type that are super tricky. Pause this video, slow it down, rewind, watch these examples a couple times, everybody. I'm going to start off with the easy one, a medium one, and definitely a challenging one. Take a look at this, everybody. Suppose I had to turn 0.5 repeating into a fraction. Well, as we all know, 0.5 repeating is 0.5555555 to infinity. So, this is going to be a little tricky, isn't it? Not if you pay attention. Here we go. First thing I'm going to do is I'm going to say x is equal to 0.5 repeating. I'm just declaring a variable saying let this variable be equal to this crazy looking number. Next, everybody, I'm going to multiply this side by 10. Well, whatever you do to one side, you have to do to the other. This will make sense after you see what I'm going to do with this. It's magic. If I multiply this side by 10, I'm going to get a 10x. If I multiply this side by 10, remember, just move that decimal point one place. That means it's going to become a 5.5 repeating. Man, this repeating stuff is really tricky. I don't want to deal with that. We got to get rid of that stuff. So, I know what x is. I multiplied both sides by 10. Now I'm going to take this original fact, and I'm going to say, use that to subtract an x from this side, which means I have to subtract an x from the other side. But I know what x is equal to. They're the same thing. So if I take away an x from this side, I can take away a 0.5 repeating from that side. And that's the big trick. That's what we're trying to do, is get rid of that repeating sign. Well, a 10x minus an x, that gives me a 9x. 5.5 repeating minus the 0.5 repeating, these parts cancel each other out, don't they? And all I'm left with is a 5. That means if I divide both sides by 9, I can prove that x is equal to 5/9. 0.5 repeating is the same as 5/9. All right, everybody, take a look at that one. You're going to get one of those for homework tonight. Let's take you up to level 2, though. You're going to get one of these as well. Level 2. What if I have 2 digits that are repeating? 0.64 repeating. Well, the first thing I'm going to want to do is I'm going to declare a variable is the same as that. Now, however many digits are repeating, that's how many times I have to move that decimal point. The last time I had only 1 digit repeating, so I moved the decimal point 1 spot, which was like multiplying it by 10. Now I have 2 digits, I'm going to multiply it by 100, so I can move that decimal point 2 places. Whatever you do to one side, you got to do to the other. Multiply this side by 100, multiply that side by 100. Now, I'm going to do the same little maneuver, the same little trick. I'm going to subtract the x. I'm going to subtract the 0.64 repeating. Remember, these two things are the same thing. Whatever I do to one side, I do to the other, but that is the same thing to both sides. That's going to give me a 99x over here. This side, those guys cancel out. All I'm left with is my 64. How do you isolate your variable? Opposite operation, the same number. Let's divide by 99 now. These guys cancel. The answer, everybody, is 64 over 99. Not bad. Rewind that and take another look at that. That's a little tricky. But wait till you see this last one. Oh boy. Here we go, everybody. What if I had 2.06 and just the 6 is repeating? Well, I know I only have one digit repeating, but I got to get this guy all the way shoved over. So I'm going to have to multiply both sides by 100 this time. That means I'm going to move this decimal point 2 places, and that guy is still repeating over there, isn't he? Now I can subtract an x, or the 2.06. Sorry, made a mistake. I can't get rid of just that 0.6. I can't subtract this from that. That's not going to work. So I have to multiply this side by 10. 10x. When I multiply this side by 10, I get 20.6 repeating. I need to have the repeatings just to the right of that decimal point. Now when I subtract from both sides, those guys would cancel. This will give me a 90x, and when I subtract here, I think I get 186. Now I'll divide both sides by 90, and I'm going to have my answer, 186 divided by 90. Well, 90 goes in twice, that would give me 180. 186 minus 180 would have a remainder of 6. Cool, but that's not simplified. Can I divide 90 by 6? So that should go in 1 time 30, 2, and 1/15. Well, that one might be a little bit trickier than what you guys are going to see in your homework tonight. But good to know. We really need to practice these more, probably in class, all together. So don't worry if this is a little tricky. But please, pretty please, look back in your book. On page 397, example 2, great example. Also, the next page, on page 398, example 3, modeling real life, but it's another great example of how to convert these crazy decimals back into fractions. Okay, everybody, you got 10 problems for homework tonight. You can do the best you can on those. One of them's a review question. 10, 11, 12. 3 of them, you're just going to grab your calculator. In 5 seconds, you have that done. So you got about 6 tricky questions you guys got to deal with tonight. Give it your best try. I'll be proud of you no matter what you do. And I think that's the end of online lesson number 3. Thanks, everybody. Thanks for submitting. The easiest thing for you guys to do for me is if you can take a picture using your Chromebook and submit it on Schoology. If you haven't figured that out yet, because I haven't, but a lot of people have, check with a friend, see if they can tell you how to do it. Otherwise, if you're emailing me a link or emailing me a picture, a Schoology message, it's all fine with me. I did get one person's homework without a name on it. I think I gave you credit, but I'm not sure. Please put your name on your homework papers. If you disagree with any of my online grading so far, please let me know. I'm sure it's my fault, but I'm keeping going with your grades. So keep looking at grade books. They should be updated daily, at least once a day, and let me know if you did something that I haven't given you credit for. All right, really miss you guys. Take care. Peace.